we'll slowly get started. I think we're at time. All right, before we get started in a minute, I'll do a quick poll. In the room, tell me if raise your hand if you're a data engineer. Excellent, wow, that's great. Data science model developers, good. All right, anybody who is into infrastructure, deployments, production, great. And the last one is security, governance. Nice, you are my people. All right, I'm in security. I was more into ML, AI for a long time. And this talk is actually, the goal of this talk is to bring you all together, provide you a common language, and make sure you know when you talk about certain things, you know what you're talking about, and the other team understands. So that's the intention. So we'll get officially started. This is the poll I wanted to do, and we are going to touch on all these areas of AI, and we will be going deep, and the talk is going to be more to provide you with the content, not necessarily help you understand everything, but make sure you have the resources when you go home, back to your work, and hopefully next week, you would have enough things to kind of kick off some discussions in your team, with your team, or plan some projects and see how you want to assess security of your AI system, and then hopefully improve security, right? Ultimately, when we talk about data intelligence in the context of organizations like yours, it is putting your data, which is one of the most valuable assets that you have, in front of your data science, which is either a model or your own home-built ML model, which is going to be more of a digital twin, and then combining those two things and getting value, right? So without putting your data in front of these models, you are not going to get the data intelligence. You're going to get general intelligence. So it's going to tell you what it would tell your competition. It would be the same answer that it would give you, like when you're talking about models. But when you put your data in front of these models, you're going to get the specific answers that you are looking for, and hopefully would be helpful for you, right? So we will get started here with, my name is Arun Pamalpati. I am Principal Security Field Engineer at Databricks. I've been with Databricks for 7 years, doing primarily MLSecOps and helping customers build on Databricks in a secure way, both from the general platform perspective, but also with AI security. With me is our esteemed customer, Joe. Introduce yourself.
Hey everyone, I'm Joe Rotano. I was the AI lead at the VA on the Summit platform, where I integrated and completed the first generative AI pipeline at VA and got it successfully into production.
And Joe also actually been part of our work group as I go into the content, and he's being humble. He helped a lot on the compendium that we delivered to everybody to use, which is in that compendium, he helped with NIST 853 mappings, which he'll be focusing on. So as part of the work that we did about, over a period of 1.5 years, we built something called Databricks AI Security Framework. The motivation for this is to produce something for community. I think it's Google doing the scripting, which may be helpful at the bottom. I just saw that. So it's a community help by community. Within the Databricks, we have about 30 people contributed to this work. And outside Databricks, I would say another 40, 50 people, either as a reviewer, as a contributor, including Joe himself, contributed to this work. The goal was to produce something that is generic enough for anybody who is practicing data and AI can take advantage of this. Of course, we are Databricks, so if you happen to be Databricks customer, we leave you with the specific controls with Databricks documentation, links or tutorials or configuration, so that you can immediately jump on and check your environment or make sure somebody in your team knows about this and they configure in a way or practice in a way that is prescribed by us if you are using Databricks for data and AI, right? So all of the work that we did is publicly available. It was published a few months ago. The first one is the white paper itself. It's 110-page document. My joke is that if you can put that in front of Notebook LLM, make a podcast, listen to it on your commute. But the most useful one would be execute ebook that is worth reading line by line because we distilled that large white paper into a simple, easy to understand, and something to practice. But the most important one is the compendium itself. It's a Google, publicly available Google Sheet. You can find the link from the white paper to that. You can download that. It's also available as Microsoft 360 document, if that is what you use. You can download that, and in that, everything that I'm going to talk about, we go at length about each of the risks, controls, descriptions about those, and mappings, which I'm going to show you briefly in the document, right? So as part of the framework, we wanted to give a map, a picture of AI, because when we talk about AI security, you hear a lot of noise around there on Twitter. Sometimes somebody publishes a PhD paper saying that they kind of compromised a model. That is all well and good. It's important that somebody is doing that. But when it comes to enterprises, you need to understand what are the risks that are relevant with respect to an AI system, not just a specific model that you may or may not be using, and what you should be doing with those, how you should be addressing those risks, right? So what we did was to make all the different types of teams that I kind of earlier did the poll on, how should data engineer think about what their responsibility is as part of being in this AI system. What should be the data science teams, the people who bring models into their environment, what they should be doing, what should be DevSecOps should be doing, and also what should be the admins and security teams, the governance teams should be thinking about as they implement. So we identified 12 different components that makes up an AI system, which I'll show you in a bit. And then at each one of those 12 components, the blue numbers are the component numbers, we identified specific risks. So these risks are by studying different standards like OWASP, LLM Top 10, NIST 853, NIST CSF 2.0, and MITRE ATLAS, MITRE ATT&CK. We took everything, and then we started placing them, right? Where would this risk belong? And then we documented the risk. What is the implication of having that risk? What would be, even if you're an assessor, what would be the business impact if you leave that risk in the system? And then you can even work with your risk team to figure out what would be the financial implications if you have that risk in the system. And then that's where most of the standards and I would say recommendations kind of take you up to. But as a practitioner, as having hundreds of thousands of customers practicing data and AI with our platform, we also want to give you controls. What controls would mitigate those risks if you deploy those in a way. How to reduce that risk is the purpose of this paper, and we identified 64 controls, which are also available as part of the paper, right? So this is the comprehensive kind of high-level, I would say, picture of AI, where everything for the AI starts at the right or on your left there, where you start with the data, you do data prep. This is where your data engineers come into picture. They will be taking in this data and then extracting the columns and making sure that it's clean and extracting features. And then they create data sets or clean files, whatever that is as you produce. You need to catalog them, make them available. You need to govern them, label them, and you need to have some kind of security controls, masking of the data. And you need to have those in a way that it is discoverable, but at the same time it has the necessary authentication and authorization. So that is the first group which I talked about, as 4 blocks into AI system. So that's where the data engineering side of the responsibility kind of relies on, right? So when you have that data, then you start thinking about AI. So this is where you either build your custom traditional ML models from the data, or you take the data, do some kind of RAG, and use some external models that are available either as an endpoint, like at Azure OpenAI, or other like Anthropic models, or you may use one of the foundational models that we curated and red teamed and make them available as part of our Databricks platform. So you get to those models, and you put some data in front of that model, right? And then you make this model as a service as part of your serving infrastructure, right? You're going to either bring that model, build that as part of your own deployment, and make that available to the applications, or you will just call a model endpoint that is hosted by somebody else, right? Once this model is in operation, or the model agents are in operation in your infrastructure, they continuously are going to need the access to the data one way or the other to make most recent fresh decisions on your own enterprise data, right? That is going to come in the process in the form of either RAG, or the agent is going to call in to do a vector search, or it is going to call into a catalog to do a query to answer certain questions. So there is continuous conversation going on between these AI systems and the data systems that you have. So in this process, as you interact with these through applications and users on your far right here, all of that needs to be monitored. You need to have some kind of auditing happening on your AI system. Who called what when, what kind of prompt was sent in, what kind of response went in, and everything in between that's happening. Like if there is some kind of authentication failure, you want to log that because maybe they don't have access. They're trying to reach into that, right? So that's your monitoring side. And as these systems are being used, there will be some feedback coming. Like somebody is giving continuously a response to a prompt saying they like this response or not, or somebody may be teaching the AI to do something else. So that needs to go back as the reinforcement learning with human feedback back into your data set, right? That becomes a fresh data that again goes back into the AI, so that like an AI is becoming improved and better over a period of time. And you're going to host all of that on top of some kind of platform with your own CI/CD process and your own DevOps, so that you have these operations that are happening on the platform. Okay, so this is kind of high-level picture of AI, and at each one of those 12 components that are in blue, you will see the actual cataloging of risks that we did. So the number next to that blue number, which is in an alert with 11 in component 1, and number of risks in component number 2 as 4. These are the risks that are identified by various standards that we wanted to make sure are well known to our customers, and they are going in with eyes open. And as you can see, it kind of stands out. It was not an accident. It was not something we planned in a way that these numbers, but as you can see, at both ends, you have the higher number of risks. So as the data is flowing in, your enterprise is either gathering the data from other organizations, like if you are a loan processor, you may be getting credit scores from third party, right? What if there is some data poisoning there, or like you are crawling some data sources? So at the source of the data, there is a lot of possible compromises, risks that can happen, and people are usually keeping those systems a bit more loose as opposed to the systems in the middle. And then on the other end, where you're actually exposing your applications, there is again higher number of risks because there can be prompt injection happening from the inference request here on the inference side, on the integration side. There can be abuse of credentials happening, or like there can be privileges that are not set right, where some of the enterprise applications that should not be giving access to some of the employees, maybe they are exposing because those endpoints are staying in the plane. plain sight, or maybe you don't have some kind of perimeter security like IP allow list or private link. So your endpoints are there open in the internet, so you need to think about how you protect those. So as you can see, those risks spread across, but the risks tend to be more on the either ends of the AI system, right? So you may say, like, okay, I understand they are there, but what is the full comprehensive list? This is the list of risks that we cataloged, and in the Excel sheet that you would be able to access, anybody can access those. It's publicly available document that we delivered as a compendium. At each one of those risks, you would be able to identify who else is talking about this, which standards are calling for educating yourself about these risks. You will find that. And you can see the ones in the dark color are like traditional cybersecurity risks. These are the things that you should be thinking of anyway, whether there is AI involved or not. If you are doing business intelligence, BI applications, or simple ETL, you would still need those controls, or you would still need to think about those risks, right? And the ones in the red are influenced by the novel risks because of AI getting introduced into your platform. So you need to think about, some of them may be like in the new form, like prompt injection. We are familiar with SQL injection, but it takes different shape. So there are a few items out there which are taking different shape, but may be known to you in a different shape and form. So, but the important aspect, the reason of this listing is that first we need to know comprehensive list of risks. Once we know what risks are there and where they may appear and how they're relevant to your use of AI, like for example, one of the things you would see in the list is model theft. That is something subject to, like if you build a model, if you pour in your intelligence or your team's process to build that model, and if it is your enterprise's proprietary model, then you need to worry about model theft, right? But if the model that you are that is in discussion is anthropic model, in the shared responsibility, you don't need to worry about if that model is going to be stolen by somebody. That is the responsibility of Anthropic. You need to be concerned about the credentials that you have for your organization to access Anthropic, and those credentials are not stolen, those credentials are saved properly or secured properly and used by right people so that you don't pay extra money for those credentials being abused or being shared and are lost, right? So not every risk that is listed here applicable to every use case. So you need to think of how you are using AI, like which risks apply to you based in the shared responsibility model, and which risks are applicable to the vendor and our different team, right? So in the worksheet, we mapped each one of those risks to the way you use AI, like is it pre-training of your own ML, are you using external model? So we kind of tag them so that you can filter down on those risks. Okay. So now this is the important piece. Now that we understand those risks, how do I implement the controls that are necessary to mitigate those risks? So as you can see in the list just by looking at the name, there is no Databricks product or Databricks capability in the control. The reason is we wanted it to be applicable to anybody who is practicing AI. Single sign-on, setting up single sign-on multi-factor authentication is something that we call on the data and AI platform and the data and AI system. How you implement in Databricks is up to our documentation. How you implement that in another platform is going to be based on that vendors. But the important piece is, do you have the necessary authentication, authorization controls on the AI system? And it goes all the way to AI gateway and so on and so forth, right? So that the idea is to give you the comprehensive list of controls, and each one of those risks that you saw in the previous slide is mapped to respective controls. And these are the Databricks platform capabilities that are going to help you implement those controls that you have seen if you happen to use Databricks. If you're not using Databricks, you should ask your vendor, like, hey, I want to deploy a specific control. Can you help me find, how I can arrive at a specific control, right? So these are like, by using certain platform capabilities, number of controls that you get. And again, for each one of those controls, in the worksheet that you are going to walk away with, you would find documentation links so that you know what we are specifically talking about for each one of those controls. So to summarize, with the Databricks AI Security Framework, you will be able to start with a use case and then look how you're going to, how you're going to basically use AI, like are you doing predictive ML, are you doing foundational model, so on and so forth. And then you can filter in the worksheet what specific risks that you should be thinking about, right? So that is going to be the risk that less than 62, the max risk that we documented. Once you identify the risks, hopefully maybe there are 40 or 35 risks that are going to come because based on how you're basically practicing or using that specific AI model, now you're going to look at what controls would mitigate those risks. So you would be able to identify those controls and then find the documentation links and make sure if they're out of the box from Databricks, you have them. If they're configuration, you need to go and make sure you harden the workspace with that specific configuration. If it is implementation, you need to identify how to implement with the documentation that we provide and make sure you kind of understand that those specific controls that we talk about. Some are ML process, some are basically simple way of using Databricks platform, and then you will be able to deploy those controls. So with that, I'm going to give mic to Joe, who actually helped a project by being part of DASF and also by using this at his at Veterans Affairs. So he would walk you through the process of how they met NIST 853 control and then summarize the process that they followed so that if you are in similar situation or similar environment, you will be able to learn from that and hopefully be able to practice that.
Yeah, for those just joining us, I'm Joe Rotano. I'm a computer scientist and AI researcher. I led the effort on DASF to map the NIST Special Publication 853 controls with DASF, and I use that as an overlay to help where NIST lets us down. And what I'll do next is walk through the 12 steps, essentially. I chose, just one part of each 12 just to talk through it, and I look at it through the lens of a federal assessor. So usually, these are high-stakes environments, Department of Defense. The VA is a high-stakes environment with veteran data, healthcare data. And the assessor comes in and they'll ask specific questions if you're following the cybersecurity guidance, and you have to show evidence, so it's all evidence-based. So what I did when I did this mapping was I looked to see where NIST was strong, like with access controls, and then I found where DASF really shined. And for the last several years as an AI lead in the AI space for federal government, I just found it increasingly difficult to take executive level input about guidance on, the strategic level guidance for AI and implementing it, and then getting it right down into the tactical controls that we needed. And this is where DASF really came in to help. So let's walk through some of those. All right, so again, the CLEVER pipeline. The CLEVER pipeline, we chomp on around 1.5 million TIU notes a day. And those notes are used for, to identify 20 types of clinical events, including those that impact mental health, medication safety, and broader social risk factors for veterans. It's an enormous task. I want to give a big shout out to Michael Slentz and Dr. Suzanne Tamang, who led that effort. But implementing it and getting into production fell to me. And so I had to stay one step ahead of the security cycle because, most of the folks in cybersecurity don't know anything about AI. They don't know the risks, and they're the party of no. Especially in the federal landscape, it is very difficult to get AI capabilities instituted. The chief AI officer is like, rah, rah, let's get this done. The CISO is like, no, not on my watch. We're not going to do it. So you have to show them where the risks are. And DASF does a really great job outside of NIST on how to do that. All right, so the CLEVER pipeline, does it build? Yeah, okay. Let me just build it. All right, so I just went over the CLEVER pipeline, 1.5 million notes a day. We chomp on that in a Spark infrastructure. It costs us something like $15 a day. And then when we overlay it with an LLM for the social construct, it's like another $5. So this is where cloud computing really comes in and helps, because we are really doing some serious work. But to get that into production, like I said, was really difficult. So when we're scaling, generative AI in the federal space, two categories emerge very quickly. We've got the traditional cybersecurity risks, and then we have, that deal with access control, encryption, audit trails, and then you have the AI native risks that are very new and very foreign to the cybersecurity team. You got things like model hallucination, data poisoning, and adversarial prompts. And so NIST 853 gives us a strong foundation, but it wasn't written with the LLMs, foundation models, and multimodal AI in mind, right? So NIST, this is where DASF comes in. The model explainability, the prompt injection resilience, the data set lineage, and the continuous evaluation. So we applied this full mapping to CLEVER. We're going to go into that. So you saw the sort of chart, and Arun talked a little bit about each one of these. I'm going to go into depth. Now, what I did was, our chief AI officer at the VA was very involved in the AI use case catalog. So he wanted to know how this would be applied to all of them. So we just started racking and stacking the use cases. We started with CLEVER, but AI Assistant was another one that had a whole different set of risks that we had to address. So let's start with the first one, insufficient access control. And I love the way this is laid out because it's in steps. You start with the raw data. Now, we begin the same way a federal assessor would. So we got to ask the questions, what access controls are in place? And you got to provide evidence. How are they authenticated and authorized? And then, are the controls suitable and federated and policy aligned? And this gives us a strong start here. So AC1 sets policy, AC2 manages accounts for user lifecycle, AC3 for enforcing access decisions, AC6 for implementing least privilege. That's a big one. You got to pay the piper each time you want to do something. IA2, identification and authorization. But while this works well for general IT systems, it's really not enough for specific access patterns. So the DASF ones comes in and shines on specific cybersecurity controls. So on the AI stack, I'm sorry, I got to look at these notes because it's very detailed. So DASF 1 and 2, you implement SSO and MFA and group-based inheritance. That's really important, but it works really well with AC1 because now you're seeing the mapping. So the cybersecurity folks are like, oh, okay, so we have this under control already. We're already doing that. And then DASF 3 and 4, IP allow lists and private links. Private links don't show up too much in the AC controls, but it does here in DASF. DASF 5, enforce granular access control and secure sharing of models. NIST doesn't do anything dealing with models at all, and this is where DASF shines again. DASF 59 and 55 leverage clean rooms, right, for collaboration and audit logs. So without strong access control at the raw data level, you're not building a very firm foundation. So your AI system is vulnerable from the start. So you got to start there. So the next one is pre-processing integrity. So we have to ask two core questions here. Are the transformations accurate and reproducible? A lot of times the federal auditor or assessor won't see what's behind the scenes, so you have to figure out a way to show the evidence. And so a great way to do this, and I'm going to give a hat tip to MLflow. MLflow is a great way to, as you're doing your experiments and your evaluations, to record each step in the phase for DASF. So in this one, we use the NIST controls SI7 and AC6, and that ensures that the software and information integrity is good. But that's where, this is where DASF 2.0 shines again. DASF 7 and DASF 11 enforce data quality checks. and lineage capture. Now, in the NIST ones, we don't really do a lot about lineage. DASF 15 and 16 provide structured tools to explore and secure data during pre-processing. No notice at all in the NIST framework to do the pre-processing. DASF 42, this is where it starts introducing data-centric ML ops and LLM ops. Again, NIST doesn't have any concept of that whatsoever, so federal assessors are at a loss on how to do that. DASF 52 and 55 use source control and audit logs, which is really important. You want to preserve those immutable records, so the assessor would be pretty happy about that. So the next risk is data poisoning. And NIST talks a little bit about it, but we have to address it again as an assessor, and we ask some questions like, how are the data sets validated before training? Or what mechanisms exist to detect and isolate corrupt data? Or are you tracking provenance and lineage of fine-grained level? And NIST controls start with SI7, help ensure data integrity, and that works pretty well. But SC28 ensures data is protected at rest. It doesn't speak to model contamination at all, and this is where DASF again shines. So the stakes are pretty high. You're trying to build a foundation here at the data level to ensure your AI is working as designed. So as we keep moving through, we get next to risk, lack of traceability and transparency for the model assets. So this is really important. You want to be able to assess, the full life cycle visibility from data collection to the model deployment. And it becomes impossible to ensure the trust and accountability and reproducibility, right? These are sort of the governance risks that we have to worry about. And so some of the assessment questions you might want to ask yourself is, can you trace every transformation that the data set has gone through or the model has gone through? Do you have oversight into the changes made to the training pipeline, model parameters, and artifact version? Again, MLflow comes in, and that's what I use all the time to just trace, what's going on with the data set, how I changed it, how I trained the model. So if the answer is no, and you haven't done that, then you have introduced a major blind spot and potentially a non-compliance system. Now, I have one chief AI officer that I'm working with right now. He's all about evaluating the model. And, what are the model details? How was this evaluated? Did you have a human in the loop? So NIST, again, gives us AU6, which is audit review and logging, and then SI12, handling and retention of information. These controls help, but they don't go far enough with the versioning, lineage, and model asset governance at the speed of AI development.
Yeah, so maybe let's show the worksheet. So there are for each one of the risks that are there in the compendium, Joe built a comparison and a contrast and the process. So with that, what we did was, if you look at the compendium, which is this worksheet that you are going to be able to download, right? So at the risk level, you have access to, first of all the risk set, right? So each risk description, and then you can see what controls are needed to mitigate that risk, so which is going to be in that other sheet, which is here in this sheet. And then the actual applicability of that risk based on your use of AI, how you are basically taking advantage of AI, so that you know if the risk is applicable to your use case, your way of deploying or not. Ooh. All right, I just realized we can only show slides, I guess. Thank you.
Yes, suffice to say, those steps are really important to kind of unearth the risks that you're going to go through for any of your AI use cases. The AI use cases are really important to go step by step through that process to unearth these risks and then provide those controls, because then you show the federal assessor which controls you're putting in place and what maps back to the NIST framework. Now, I'll be talking with the NIST team next week about integrating some of the DASF controls into the next NIST Special Publication 800, probably Rev 6. So, because it doesn't really handle anything to do with AI. So this was me painstakingly going through and mapping each one to showcase where we're kind of missing for AI. Because the speed at which the adoption of AI is happening is just overburdening any federal standards, right? So I don't know if anybody in here does, federal compliance, but it's a rough crew to try and get your AI capabilities through. But DASF comes in and really helps out and shines and helps to unearth the risks, so you have this sort of risk catalog, and then you apply those controls, and then you provide the evidence to the assessor, then you get that full ATO, and then your AI is in production. That is probably one of the hardest things to do.
Yeah. All right, we are back to sharing the screen, sorry. So here is the worksheet that we wanted to show you, and for each one of these risks that Joe was going through, the risk description, whether that specific, what controls you would be needing to mitigate the specific risk. And then you will see, whether that risk is applicable to certain type of use of AI, and then the risk impact, business impact, and you will see the mappings to the standards. So you will see, who else is talking about this risk, and this is what the NIST 853 mappings are going to, the mappings that Joe is talking about, right? So, sorry, Joe, I didn't mean to interrupt you. You can take it from here. I just want to kind of call that these things are not, and also for the controls, right? For each one of these controls, you can see the Databricks documentation links and how to deploy a specific control, and you will see here again the standards that are talking about this, and NIST 853, that is the full mapping of the work that Joe is talking about.
Now, will they have access to the PowerPoint?
Oh, yeah, they will be able to get
So once you download the presentation, you can click on all these links. These are resources that you have.
Yeah.
The question banks that I created, I have full question bank, about 102 questions that you can ask your own ML ops pipeline to see where you're missing, see if there's any gaps in your risks. So we got, 5 minutes left? Do you want to ask questions?
Yeah, and let's go to the summary one, and then we'll conclude. Yeah.
Okay, so what did we do? So for the VA, we mapped the NIST 853B with the DASF overlay to help us get across the finish line for a production environment that helps veterans. And so, right now, the company that I'm working at now, I'm taking the DASF overlay and I'm integrating it into our compliance tool so we can do continuous ATOs. So that's the key here, is to get these AI capabilities into production faster, because it is taking a long time. So those control mappings are really important. I guess that's the key point.
I started by asking a question, based on your role in your organization, the goal with the overall Databricks AI Security Framework and all the mapping is based on where you are in your organization in the AI system. We wanted to give you, first of all, a common language when it comes to AI security. When you're talking about certain risks or certain controls, hopefully now by using this framework, you have a way of communicating with your security teams, your governance teams, your risk teams, making sure when they ask questions, you have the ability to show them that you have deployed certain controls, or you are in the process of deploying or proving that you deployed, so that they can actually think of moving your workloads or your AI applications into production. Because in a regulated industry, you need to have certain level of deployed control proof set so that you can actually move into production or be compliant with certain data sets or certain AI applications. Without that, you will be either, at best, you are going to be slow to production, and in some scenarios, they will say the cyber teams or the risk teams or governance teams, you're going to keep on running into no, you cannot do that. And our hope and our goal with this is to kind of enable you with how to get to those control sets and make sure you deploy those control sets by working with various personas within your organization.
and so we're at time. So take one question or two
Yeah.
questions?
So this is the summary slide for you all with the project that Joe was on, what challenges they had, what solutions, and how they overcame those challenges, and what kind of results they got. You can see that, but while we wait on that slide, if there are any questions, we would love to answer one or two questions here, and we'll stand outside to address any specific questions that you may have. All right, thank you all.